Hey guys, Mr. Jenkins here with your final lesson of Chapter 6 that we'll be covering. So remember, you'll have a test coming soon over the second half of the chapter, which would be sections 6.5 through 6.8. And this lesson in particular, 6.8, is all about graphing radical functions. Okay. So with that said, we will just get right into it. So we're going to be looking at the graphs of radical functions and their domain and range. So what you can do here is just use your graphing calculator to produce these graphs. All right. But one thing that's going to be pretty easy to remember here would be that basically what you want to do if your input goes under the radical, you would want to, the easy ones would be your perfect squares. So like 1 is a perfect square, not 2, not 3, not, well then 4 is 5, 6, 7, 8, and then 9 is, right? Those are your perfect squares. So if x is 1, y is the square root of 1, which is 1. So 1 goes to 1. Actually, you would want to have 0 in there too. 0 goes there too. So you have 1, 1, 0, 0, 4 goes to 2, and 9 goes to 3. All right, so that's kind of your basic shape, right? That would be the parent function. And, if you needed points in between, what you would want to do is use your graphing calculator. See, I've gone to y equals and type the square root of x. Now I can go to, first of all, visual, see that my graph appears to be correct. And then I can go to a table to get more points. So they're going to give me any of the points I want. So 0 goes to 0, 1 to 1, 2 goes to 1.4-ish. So depending on how detailed you wanted to get. Well, I'm not even going to write those in, but you'll see on the filled out notes that I filled out anything and everything in between. But the ones you want to focus on are 0, 0, 1, 1, 4, 2, and 9, 3. So that gives me the basic shape of the graph. That shape should look somewhat familiar, at least partially. Kind of looks like a sideways parabola, right? Or at least one side of a sideways parabola. And think about inverse function rules and why that kind of makes sense. So my domain, what x values could be included? Say -1 goes to error, right? And so that means it's never going to go to the left of this point. So that would be any x greater than or equal to 0. And then my range would be any y. So now I'm looking at any vertical limits. So it doesn't look like I can go below 0, 0 either. So that would be any y value greater than or equal to 0. All right, now let's look at another one. So y equals the square root of x plus 1. So I'm just going to take what I've already typed and just arrow over and add a plus 1. Look at my graph, and it looks like pretty much the exact same shape except shifted left 1, right? And you may have remembered that from what we talked about with transformations, right? F of x plus 1 would be right 1. Okay, we talked about that a bunch in the first semester. It's right 1. So to get our actual points then, we can go to our table. And this time, -1 goes to 0. Whoops. All right. -1 goes to 0. 0 goes to 1, 3 goes to 2, and 8 goes to 3. All right, so what's my domain in this case? So this is kind of like, we kind of treat this like our vertex of a parabola, kind of like that starting point. So it's -1, 0. So my domain would never go to the left of -1, so that's any x greater than or equal to -1. My y value never goes below this, so y greater than or equal to 0. All right, now before I do anything with this, I'm going to skip this one over here because we've dealt with those enough. That'd just be a parabola. Let's go ahead and look at this one, which would be an f of x minus 2. So the minus 2 outside the parentheses, what does that do? Go ahead and answer that. The answer is it's going to move us down 2. Okay? And if you didn't just remember that, then you could have used your calculator to help. So go back to y equals. I'm going to just clear out what's there. Type square root of x, arrow out, and then minus 2. Look at my graph, and now I can see it's kind of just the parent function shifted down 2. To get specifics, I'm going to go to table. Shift down so I can see 9. So it says 0 goes to -2. 1 goes to -1. 4 goes to 0. And 9 goes to 1. So again, just our parent function shifted down 2 units. So the point that we care about to come up with our domain and range is here, 0, -2. So my domain would be x's never go to the left of 0, so x greater than or equal to 0. Y values never go below -2, so y greater than or equal to -2. All right, so just continuing to move on here. I'm going to leave example 3 there for you. Y equals negative absolute value of x, and we'll talk about this last one. So this last one, before I use my calculator, I'm going to ask you, what would this do? So we have 2 times f of x minus 1. So in this case, we have multiple shifts. All right. So what are those 2 things, 2 transformations that are happening to the parent function? All right. So the answer to that was we're not really asked to do this, but I think it's important to see anyways. Answer would be a vertical stretch, where a equals 2. And also, an x minus 1 is going to move us to the right 1. All right, so let's see it in our calculator now. All right, so I'm going to do 2 square roots of the quantity x minus 1. I'm going to look at the graph, see that it does appear to be stretched, and move to the right 1. Okay, to get my specifics, I'll go to second graph to look at the table. So I want to do 1 goes to 0. 2 goes to 2. 5 goes to 4, and 10 goes to 6. So 1, 0, 2, 2, 5, 4, and 10, 6. All right, so this is the point we care about as far as domain and range goes. Just 1, 0. So what's my domain? This function is never going to go to the left of this point, so x greater than or equal to 1. And then does the stretch affect my domain, range? The answer to that is no. We're still going between 0 and infinity. With the stretch, we just, in theory, get there a little bit quicker, right? So y is greater than or equal to 0. All right, so nice, quick, easy lesson here. A lot of using technology. But as always, if you have any questions, let me know. And this will be our last lesson in this chapter. So due date's coming soon. Thanks, guys. Have a good one.